start from the current slide. Okay, so we'll get started in just a few minutes once we get shown in here. Okay. All right. Anyone else come in since the call roll that I did not acknowledge your presence? Okay. First, I think I've announced this before, but just in case any of you weren't here to hear it or forgot about it, if any of you were in a first mini-term course or know of someone who was in a first mini-term course, they were very late getting the student course evaluations open for that course, but they are now open. They usually leave them open a little while, so please get your student course evaluations done. Okay. And that brings with it another issue, and that was midterm progress reports, because we're now in the second mini-term, so midterm was last week. Sometime this week, they'll probably ask for midterm progress report. Now, that's when they have us tell them any students who have D's or F's at midterm. Okay? Now, this class did a very nice job overall of getting in your first quiz. Still missing 1, 2, 3 first quizzes. And, and I made a copy for Jalen. You said you had graph paper, right? Okay. So you need to get that into as soon as possible because I have no score for you. Now, the other option, of course, is to have a research paper turned in. And let's see, this class we have, my biggest class, we have 0 research papers turned in so far. And we're past midterm, okay? Please, folks, be working on your research paper, okay? And like I said, 3 people haven't even done the first quiz, so I have no scores for them. If they ask for it today, I've got to put down that it's failing at midterm. There are a few others who didn't do that well on the quiz, not that many, but a few. I'd probably have to put down you have a D at midterm. So please get those in. Now, about the test, okay? Dr. Thomas said that some people turned in the test not finished way early. That makes no sense, okay? Get your name, please. Well, right. You get my pen. Okay, say again. Simmons got it. Okay. Alexis. Okay. If I had been here, here's what my response would have been. If you're turning the test in early, that indicates you're through. I will grade what you got now. Okay. If you're still working on the test, keep working on the test. The end of the period, if you aren't finished, then is when you put not finished on the test. So she let you skate with that. I didn't specifically tell her that because I wasn't anticipating anyone doing that. But if I had been here, that would have been my response, okay? So that is not to happen again. Okay, Zach is here. That can't happen again. Okay, so please, now. Okay, well, every day I ask, are there any questions? We worked through all the problems. Did you do all the homework exercises? Yeah, yes, or you did all the homework exercises? That was just like the homework exercises. Hey, the same people who do the homework exercises did the test. Okay, it's from the test bank. It's there. We went over everything that was on the test in class, usually multiple times, okay? So when I say, are there any questions, that's the time to ask questions, okay? If you're having trouble with the homework, like I said, there are these sites in the book, Larson Calculus, precalculus.com. There's calchat.com. There's calcview.com. If those things can't help you, bring your questions to class, and we'll go over them in class. Okay? Say again? James. Got it. Okay. Web, right? So, that's the time to ask questions. Anytime you don't understand something, ask the question. But everything that was on the test was just like stuff we had gone over in class, and just like the homework exercises, just like the checkpoints. Okay? So if you need to, start bringing me your homework every day, and I will go over anything that you seem to be missing. So that might be a good way to make sure you're ready for the next one. Okay? Or, if you still got your homework, bring it, and when you go to finish this one, you can do that. But what it indicated to me was that there weren't enough questions asked, and I could see fairly little evidence of anyone doing any homework. I don't know if you did or not, but it's all there. And please ask questions. Please. Okay. So, I think all but one person indicated you weren't through. Now, some people haven't taken it, so you got to finish this during my office hours. I don't have any office hours, especially on Tuesday and Thursday. So you're going to need to work out a time with me. But my office hours, my biggest chunks of office hours right now are Mondays, 8 to 10, Mondays, 3:45 to 6, Tuesday, 8 to 8:30, 12:45 to 1:15, 2 half-hour periods, and then I'm usually here after 5:45. That's when my lab gets over with. I'm sorry?
May you repeat that again?
Okay. My office hours on Monday are 8 to 10, 3:45 until 6. Okay, last night I was here way past 6, way past 7. Okay, I'm not way past 7 every Monday night, but I was last night. Okay, Tuesday, all I've got are 8 to 8:30 in the morning, that's half hour. 12:45 to 1:15, that's a half hour. That's usually when I eat, but I'm eating in my office, and that you can come pick it up then. And after 5:45, like tonight, I'll be here well after 6 o'clock. Officially, I leave at 6, but I'll be here after that. Name, please. Huh? Counsel, got it. You're a Cordarian, right? All right. Yes. Well, can I finish my office hours?
Yes, sir, you can.
Okay. All right, that was through Tuesday. And by the way, Thursday's just like Tuesday. 8 to 8:30, 12:45 to 1:15, and after 5:45. Okay, Wednesday, 8 to 10. Okay, that's about all. I've got a little bit of time from 11:45 until 12:30. 45 minutes there, so you can come then too. 11:45 until 12:30. Because Wednesday afternoon, as soon as my last class on this campus is over, I've got to book it to the Birmingham East campus to do a physics class, so I have no time in the afternoon on Wednesday. Thursday was just like Tuesday. Fridays, I'm on the Birmingham West campus, 8 to 12. Just about every Friday. Now, they love calling meetings on Fridays, and I'll let you know if I know about a meeting, but sometimes they'll call them Friday morning, and I won't know about them. And occasionally, I either have a doctor's appointment or something else that comes up on Friday, meetings or other things that I just can't control. Occasionally, I have to go out of town either for a meeting or something else. So anyway, those are my office hours. Now, if the period right after this class is free for you, even though I have another class, I can't remember if the room right next door is open then, but if it is, you can, right after this class is over, you can work on it next door in that room, if there's no class there. If there is, we'll find another room. Okay? So that's another option, because I do have a class right after this one, but I will do it. Okay. All right. Any other questions? My office? Okay. I'll show it to you on this. You go out this door here, hang a left, go down that little half flight of stairs there right by the restrooms and the corridor that goes over to financial services. Go past that to the end of the hall. Just before you reach the end of the hall, there's the last office on the left is 265. Right before the stairwell, going downstairs or upstairs, and right across from the orientation classroom. Okay. All right.
You said 265.
I'm sorry? 265. Yeah. And you had a question? You had a question? Yeah.
Yes, I was gonna ask you about Friday.
Yeah.
Because my schedule's kind of tight, and so, but Fridays I'm free. I do work study over there on Birmingham campus.
Right.
So that's majority of my time on Birmingham campus because I be here. I got to shoot over there.
Right.
So I was gonna ask you, can I come Friday?
Yeah. But be sure you let me know Thursday so I can put your test in my grade book, so I'll have it over there.
Okay.
Here's one of those unusual circumstances that had me not on Birmingham campus last Friday the whole time, because I was over there working, and a student came in. I need to take my final. This is from the first fitting term course. I said, well, you didn't tell me you were coming. He said, no. I said, well, I don't have the final with me. So we had to come back to the Vassar campus, and I had to get his final and give him his final. Grade his final, because it was a mini term course. So I was just going to work over here the rest of the time. Then I got a phone call from that campus, and two of my instructors needed to meet with me. So I had to drive back to the Birmingham campus. So there was an hour wasted driving back and forth, mostly because the student had told me he needed a test. Okay, if he had told me, I would have had one more hour to work, and I didn't. I was in the road. So please let me know Thursday if you're going to be taking the test on Friday. Okay? So yeah, that'll work out very nicely. Now, if I wind up in a meeting, I'll leave the test with the secretary, Ms. Rose Saxton. You know where Dr. Pruitt's office is?
I know Ms. Rose.
Huh?
I know Ms. Rose.
Okay, yeah. So if if I'm not there, if I know you're coming, I'll leave the test with her.
Okay.
All right. Any other questions? All right. So, we're in Chapter 2, Section 2.1, and this is, Chapter 2 is polynomial and rational functions. Right now, excuse me. We're with polynomial functions, and we're in 2.1, focusing on quadratic functions and models. We'll get to the models later. Okay? So, we did example 1 last time. That was top of page 116. Okay? And in that example, it said, note that the coefficient, the leading coefficient of a quadratic equation or function determines how wide the parabola opens. F of x equals ax squared. That's your close to the simplest parabola you have. Okay? It goes through the origin when x equals 0, y is equal to 0. Okay? If that a is a, okay, first, let's get the, forward, got it, electricity. All right, okay. Okay. First, let's just get this out of the way. If that a is positive, it's opening upward. If the a is negative, the parabola is opening down. Okay, so let's get that out of the way. But what they're talking about is the magnitude of the coefficient. If that coefficient is between, of course it can't be 0 or else that's not a quadratic, okay? But if it's between 0 and 1, in other words, a small value for a, that means it's a very wide parabola. Why? Because the y's are going up very slowly because that's a very small number. Okay? If that a is greater than 1, then they're going up more quickly. So it's a very narrow parabola. And the larger the A is, the more narrow it is. Now, remember, parabolas are always curved at the bottom. Don't ever make them pointed. That would be an absolute value function. Keep them curved at the bottom. No matter how sharp they're going up, make sure you still have them curved at the bottom. So when the absolute value of the A is small, that means it opens wider than when the absolute value of A is large, which means that, you pull the string and the hands go up. It's a very narrow parabola. So we know that the graphs of, now this is from last chapter, okay? And we did bunches of these in the last chapter, okay? Name, please. Start, okay, got it. Cameron, right? Okay. Now, we did these last chapter. If y is equal to f of x plus or minus c, let's take the plus c to begin with. What does that do? What does this do to the function f of x? If you have an f of x plus c, what does that do to the function? If you have the graph of f of x, and you know what it is, let's just say it's a parabola, what does adding c to the x do? Anybody? Yeah. Say again? Shift it, okay. Is that what you said? Which way? To the left. You're absolutely right. Because you see, you're adding or subtracting something from the x. The x is on the horizontal axis, right? So therefore, it's a shift horizontally. Now, the weird thing about the x's is, if that's a plus, it goes to the left. If that's a minus, it goes to the right. Usually, it goes the other way. But anything that x does, it seems to do it backwards. Okay? Now, what if you have this? Y is equal to f of x. There's your parent function. That could be your parabola. Plus or minus c. Let's go with plus c. What does that do? Shifts it up c units. And what does the minus do? Shifts it down c units. Because you see, you're adding or subtracting to the y value. And the y value is vertical. Okay? And that was at least one or two of the questions on the test were just like that. Okay? What is that doing to the functions? Okay? What does this one do? F of minus x. Okay, it flips it, what across? Do what? No, a minus x would be over here as opposed to a plus x over here. So it flips it across the y-axis. What does this one do? Across the x-axis, because you're changing the sign of the y. If the y was up, negating it moves it down. If the y was down, negating it moves it up. Okay? So that is changing. So those are reflections across the y-axis and across the x-axis. Now these, remember, are what we call our rigid transformations of the graph y is equal to f of x. This is a review from the last chapter. We went over these, lots and lots of examples of these. Okay? Now, same thing works here. And these are the rigid transformations. When you multiply, you see what you're doing here, adding or subtracting to the x, adding or subtracting to the y, negating the x or negating the y. Those are rigid transformations. Whatever you had here, parabola, it's shifting, or reflecting, okay? So those keep the same shape, it just moves it around the graph some, flips it over, something like that. When you did this kind of stuff, multiplying by a value, that's your stretches. Those are your non-rigid transformations. We've just been talking about those without using that term. And that you also had on your test, and we had in the last chapter as well. Okay, now, For instance, in the figures below, notice how the graph of y is equal to f of x, that's the gray graph right here. That's your good old parent parabola. Y is equal to x squared, okay? Parent function. Can be transformed to produce this one. Now, what is this one doing? What would you say the transformations of that was? Here is the gray. Y is equal to f of x squared. Y is equal to x squared. F of x equal to x squared. What is the black graph doing? Say again? Okay, it flipped. So what did you have to do to make it flip? Say again? From the last slide. What made it flip across an axis? One of those 4 or 6 things at the bottom. Which one of those flipped across an axis?
The x plus minus c.
No, that was a horizontal shift, not a flip. Next guess? Well, what was this flipped over? This is flipped across the x-axis. So what did that? Negative f, exactly. You negated the x squared. So that's the first thing you did there. Negate the x squared, but then you did what? Moved it up 1, right? Because negating it would have put it right down here. Then you shifted up 1. Okay, and what did that? Which one of those shifted up 1? Yeah, only the plus. Plus 1. Exactly. Do you see that? Okay. Okay. So, that's why this new function is minus x squared. That's the flip. Plus 1, that's the shift. Does that make sense? Okay, any questions about it? Okay. Okay, you reflected it, that flipped it down, and then you moved it up. Plus 1.
And so, like those boxes, it's like you just plug in a number, they get like your points.
Say that again.
Those numbers there, the little white boxes, you just plug it in your number.
Yeah.
Get your points.
Okay, yeah, this is the parent function here, the gray one. This is the new function, that's this one. You flipped this one over, made it a minus x squared, made it opening downward, then you took that thing and shifted up by 1. So this minus x squared was the flip down, move that up by 1. And you got a plus 1. Okay? Now, saw them on the last test. I have a sneaking suspicion you'll see the same type of thing on the next quiz. And guess where? Probably on the next test. And very likely on the final exam. I can't promise that, but the odds are you'll see things like this. This book focuses on this. That's why they spend so much time with it. Okay, now, here's your parent function. Y is equal to x squared. Okay? Now, what is this thing doing to that? Shifted what? Left how many? How many? Twice. 2. Okay. Now what did that? What's the left shift? Remember everything with plus 2. Remember everything with the x is backwards. Okay. So plus 2. That shifted left. But what else did this do? Went down. 3. Okay, so that would have been minus 3. The y is going in the right direction. So g of x then would be x plus 2, left shift squared, because you do that to the inner part, the x, and then the outer part, you go down 3.
Okay, I got another thing.
Okay, again?
So you making this up, you made up your own equation.
Okay. Yeah, you're telling what this equation is based on what that one is. Yeah. So you're creating it. Here is what it is. That was drawn for us. then you figured out what you did to this to produce this. You shifted left 2, that's an x plus 2 in parentheses squared, and then you went down 3 minus 3. Yeah. So you did the work there. And you need to be able to do it both ways like you saw in the test. It could give you the description of what was happening, and then you come up with the equation, or they give you the equation and you give the description of what was happening. See, if they had said this one, you would have said you flip it across the x-axis and then go up 1. Yeah. So you need to go both ways, you know, offense and defense. No, okay, yeah. All right. Make sense? All right. Any questions? Okay. Now, I bet you most of you would have thought that let me see if I can find one. Ha! Right here. You would have said, oh, that's your standard form for a quadratic equation. If this would have been this thing equals 0, that's what we used to call the standard form for a quadratic equation. However, that is not the standard form for a quadratic function. It's certainly an expression of a quadratic function, but it's not in standard form. Okay? Now, I'm going to take you back in time, and I don't know if you'll remember this or not, but back when you were probably first graphing functions, and you had a function that looks, or not functions, you didn't talk about functions then, you probably had something that looked like ax plus by is equal to c. You know what? They actually called that the standard form for a linear equation. And that wasn't very standard. It sort of is, but basically the A, B, and C tell you almost nothing. Okay. You can squeeze some information out of them, but that's about it. Okay? But later you did something like this. You got it into a form that was like this. Y is equal to mx plus b. Remember that one? And what's that? Yeah, that's a linear equation just like this is. In both of these equations, both variables are raised to the first power. So it's a linear equation. But this is a far more useful equation. Why? What do we call that? Slope-intercept equation. Because everything in there tells you a piece of information. This A, B, and C tells you almost nothing. Here, what does the M stand? And what does B stand for? Y-intercept. You can just graph that equation just by knowing that. All you do is go up or down B units, however, if that's the plus or minus B, okay, and do that, and then do your slope from that, okay? That tells you exactly how to graph the equation, okay? So, when we get to quadratic functions, and by the way, your standard linear function is f of x is equal to mx plus b. They don't have anything that looks like this. That's your standard form. If you see a linear function, you can look at it and know y-intercept and slope every time. So, when we get to quadratic functions, this is not a standard form. It's a perfectly good form. It's just that A, B, and C don't tell you very much. The C tells you something, okay? And we'll come back and use that C sometime. The A, as we already talked about, tells you something. It tells you whether it opens up or down, depending on whether it's plus or minus, and whether it's narrow or wide, depending on if it's a big A or a small A, okay? So it tells you a little something. The B tells you almost nothing, okay? So we need to get a standard form that tells you a whole lot more. In fact, with the standard form, you can almost graph the parabola, any kind of parabola. And that's what we're going to get to next. Standard form for a quadratic function. Here is how it looks. Now this looks a lot more complicated to me. Okay, f of x is equal to a times x minus h squared plus k. That's how the standard form of a quadratic function is always going to look. And I will guarantee you this. You'll see this again on quizzes and tests, and maybe probably even on the final. You will see write it in standard form. Yes?
I'm sorry to jump off topic, but you said the final. But don't you have an 8, a 90 or above? You can exempt.
Oh, wait. I'm sorry. I must have read the wrong syllabus. Because I'm almost certain that in this syllabus it said the research paper and the final exam are not droppable. Oh, yeah. That was in there, wasn't it? Okay. Yeah. Okay. I made a big point about it, too. Go back and listen to the video. It's there. Okay? So, back on topic now. Okay. But good question. I encourage you to ask questions. This is what we call standard form. Now, notice before you had an A, B, and a C. Guess what? Same A as you had before, because guess what I told you? That A gave you information. The plus or minus meant up or down, and the size of it meant narrow or wide, right? So we hang on to the A. But the B, which told you nothing, don't have a B in there anymore. The C did tell you something. We'll use that C when we need to, okay? But now, what in the world could the HK be? The H and the K. Instead of B and C, we have an H and a K in here. Anyone got an idea what it is? Right here. This form is especially convenient for sketching the parabola because it identifies the vertex of the parabola, HK. H is the X component of the vertex. K is the Y component of the vertex. So if you can get your quadratic equation into this quadratic function, standard form for the quadratic function, you can pick off the H and the K. And remember, anything dealing with the X is always backwards. So if this was X minus H, you put the plus H there. If this is X plus H, you put a minus there, okay? Everything dealing with X's is always backwards. The standard form is X minus H, so if this is X minus 3, the vertex is 3 something.
Okay.
If it's X plus 3, the vertex is negative 3 something. Because it's always the opposite of what that means. X's are that way, they're just backwards. Okay. The K then is your Y component. So here we state that again. The standard form of a quadratic function, f of x is equal to a times x minus h squared plus k. Now, of course, a cannot be 0. Why can a not be 0? Because if a was 0, this whole term is 0. And then you have f of x equals k. That's not a quadratic function. That's not a parabola. That is a constant. Okay? That's a linear function. So this is standard form. The graph of f is a parabola whose axis, okay, remember that axis of symmetry? Real easy to pick out here. All you do is rather than say x minus k, you say x equal k. Okay? That gives you the axis of symmetry. I mean x equal h. I'm sorry, I said k. X equal h. If this was x plus k, you say x equal minus h. Okay? You just give it the opposite sign. That's going to be your axis of symmetry. X equal h. Whatever the h is here, x equal that, that is going to be, whatever your h is there, whatever x equal that is going to be, because guess what? You have a parabola here. There it is. The vertex is right down here. X equal that, x component of that, that's the axis of symmetry. Everything revolves around that. Okay, so you can immediately tell what the axis of symmetry is. And you know immediately what the vertex is, HK. Okay? Now, when this A is a positive number, you know the parabola is opening upward. When A is a negative number, you know it's opening downward. So there you use the H2, the A2. You don't get as much information from it as you do H and K, but you get a lot of information. Okay? Now, I would hope that in your brain you're saying, But most of the time, they don't give us those in flat form. They look more like that ax squared plus bx plus c, right? So you're going to have to get it in the standard form, okay? So to graph a parabola, it is helpful to begin by writing that quadratic function, okay, in standard form, using the process of, remember this, completing the square. Back in Math 100 probably, or Math 112, you probably did this, and you probably loved it. I know you loved it. I can't say it doing complete. No, I'm sorry. So, and we'll do it in example 2. It's coming right up. In this example, notice that when completing the square, here's the hint. You add and subtract the square of half the coefficient of x. This is so bizarre to write it this way. Within the parentheses instead of adding the value to each side of the equation. When we do it, hopefully it'll make more sense than that sentence just did. Okay? So let's do it. Sketch the graph of, this is written the way we used to write quadratic equations. Ax squared plus bx plus c. Okay? So sketch the graph of this. Now I'll tell you what we're going to use in that. We're going to use that c. We're going to use the 7. We'll tell you that in a few minutes. But it says identify the vertex and the axis of the parabola. So that basically is telling you, write this thing in standard form. So, reminding you what standard form looks like that. A times x minus h squared plus k. Okay? And here's how you get to it. Okay? This is your A right there. The A is going to stay 2. It's not going to change. But you remember that A is outside the parentheses. So here's the first thing you do. Rewrite this as f of x is equal to, okay? Now I'm going to do it this way because this is a little dumb and I like to do things dumb. Okay? I'm going to stretch this out. After a while, you won't take this many steps. Okay? But I'm going to separate 2x squared plus 8x and do my plus 7 over here. I usually call that a blank, a big long space there. Okay? So, you don't need to do that step, but I'm doing it this time. Now we're going to factor out the 2 only of the x terms. Okay? Factor that a out. So that's what we're going to do. A times x squared. I did the first one, you tell me the second one. Plus 4x. Blank plus 7. Now I might not do it the same way the book does, but it's pretty close. Okay? Now, this is the part we need to complete the square. That's why I put the blank there. Okay? Got it? You remember how to complete the square. Alright? Here's how. Once you get rid of the coefficient of x, factor it out. Now you got just an x squared here. So we're only dealing with the inside here. The 2's on the outside, we're not messing with that now. This is, now your new A is 1, your B is 4, and you don't even have a C. Okay? Forgetting about the 7 for now. Take half of that middle term, the B. And what's half of 4? 2. Okay? And then you take the 2 and square. What's 2 squared? 4. So you're adding 4 here. Okay? You just changed the problem. You changed the problem big time. Because now you've got a plus 8 here. Because the 2 on the outside is outside that parentheses. And this is 2 times 4 is 8. You added 8 to this problem. So guess what you got to do over here? Subtract that. So you don't change the problem. Okay? You added 8 in there, subtract 8 out here. That gives you the same thing as you had before. You can go through the process and find out it is the same. This will be 2x squared plus 8x plus 8 minus 8 plus 7. Plus 8 minus 8 is 0, plus 7, yeah, you got right what you started with. Okay, I was just checking. 2x squared plus 8x, that's there, plus 8 minus 8, that goes to 0, plus 7. Okay, you haven't changed the thing except how it looks. Okay.
So we basically just breaking it down.
Yes. Yes. Okay, it's the same side. I mean, not the other side of the equation. That's over here. To the, yeah, outside the parentheses. Exactly. You're subtracting what you added when you were inside the parentheses. Okay, now I'm going to give you another hint here. Okay. As soon as you take 1/2 of the b there, 1/2 of 4, you can come down to the line below and write x, half of 4 is plus 2, and put your square there. That's the easy way to do it, okay? Whatever half of this is, take away the square here, x plus 2 squared, okay? That will work. And let's check it and see. How do you square a binomial? Square the first term, x squared. Twice the product of the two terms, 2x, double that is 4x, square the last term. That's it. Or you can take it off and FOIL if you want to. But you see, this always produces that. When you take half of this b here, write it down here. Put it x plus or minus whatever it is, whatever the number is, squared. You've got it. Okay? And then, what do we do on the outside? What's plus 7 minus 8? -1. Okay. Now, we haven't sketched the graph yet. We're going to do that in just a second. Okay? But you can identify the vertex right now, can't you? What is the vertex? That's an ordered pair. What is that ordered pair? Someone tell me. H and K. You're absolutely right. What's your H in this one? -2. Remember, it's that deal with the X, you always opposite. So it's -2. And the K is -1. There's the vertex. You found it. Okay? Now, it also asks for the axis of the parabola. I like to call it the axis of symmetry, but you can just call it axis. What is the axis of the parabola? Now, that's always an equation. It's always a vertical line. Vertical lines are always x equals something. Tell me what that x is equal to. What was it? X equal h. And what's your h? -2. There you got the axis of symmetry. You got the vertex, you got the axis of symmetry. Now the fun part is graphing it, okay? So we're going to sketch the graph, okay? Oh boy. Okay, we know this is opening upward, but we know it's got a vertex that's in the negative quadrant over here. So let's tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8. -1, 2, 3, 4, 5, 6. +1, 2, 3, 4, 5, 6, 7, 8, 9. And -1, 2, 3. Okay. What's an easy thing to plot first? The vertex. Why waste your time finding it if you're not going to use it? So how do you plot -2, -1? You go what? Okay, which way? To the left 2 and down 1. There's your vertex right there. -2, -1. What's your axis of symmetry? X equal -2. That would be everything above and below there. Okay. Now, I'm going to show you what I was saying before. Not the only, but the major good thing, positive thing you get out of this is your y-intercept. Just like you did with the other, because the y-intercept is where x is equal to 0. Because when x equals 0, you're on the y-axis. You're not right or left, you're on the y-axis. So you put x equals 0, and what do you get the y to be? 7. That's what that constant tells you. So I told you, gave you a little something. 1, 2, 3, 4, 5, 6, 7. Right there is your y-intercept. Okay. Now, I'm going to show you something else. Why do we call it the axis of symmetry? Because whatever's happening on one side of that axis has to happen on the other side. And notice what happened. If you go 2 units to the right, you're at plus 7. So if you go 2 units to the left, you're going to be at plus 7. There we plotted a point, didn't even calculate it. But you know it's got to be there because it's exactly opposite that. Okay? Now, you don't have to do your graphing this way, but this is how I like to do it. I start with my vertex here, where x equals minus 2. Now I like to go either 1 unit to the right or 1 unit to the left. You choose. Which one you want to do, 1 to the right or 1 to the left? Right, okay, that'll be x equals -1, right? Okay, so at -1, we're going to plug right in here where the x is, right? -1 plus 2, 1. 1 squared is 1 times 2 is 2 minus 1 is 1, okay? So when x is -1, y is plus 1, okay, right there. And guess what? Because of the axis of symmetry, go over 1 to the right, 1 to the left, and you got another point. And guess what? That's all you can get on this graph. Everything else is going to be off scale. So that was almost no work. You evaluated 1 additional point, and you got 5 points for the price of 1. Okay, that was pretty good, right? Buy that anytime, okay? So now to graph this, come down here, make sure you don't have a point here, I have a curve, and then go back up that way. There it is.
And so the ones you got, like that one over there.
This one up here?
Yeah.
Okay. How did you get it? I first knew that the y-intercept, because my x equals 0, that's the 7. And then because of the axis of symmetry, if I'm 2 to the right here at 7, to the left, it's going to be at 7 also. And then when I chose a point down here, you chose -1. Plug that in here. This is your y, remember. Plug -1 in here. That gives you a +1. Squared is +1. 2 times 1 is 1. Is 2. -1 is 1. There's your +1. Okay? And then go on the opposite side and get that. You're done. Now, if you had a bigger graph, you might be able to do more points. But, hey, that's enough. And that wasn't too painful, was it? The hardest part is doing that, completing the square, and that's not that bad. Right? Okay. Want to see how they did it? Huh? All right, you're still writing. Okay. That's fine. And I can almost guarantee you're going to see this kind of stuff again.
Oh, okay. I got another question. So that part, the foil part, you said you were just checking it for the 2x squared plus 4x plus 4 plus 7 by 8.
Okay, say that one more time.
You said you were just checking it for the top part, right?
Okay. Right up here?
Mm-hmm.
Okay. I separate that because I want to keep my x's together and then put the y somewhere, out of the constant somewhere outside. They're all still there, but you just have a blank here. The reason for the blank is that when I factor out the a, now not every time, sometimes the a is 1. You don't have to factor a thing, so you just go from there. But if it's not 1, factor it out, which is dividing. Dividing 2 into 2 is 1, and 2 into 8 is 4, okay? That's what you do. Leave a blank here too, just like that blank, okay? And leave that on the outside. Then you take half of this b, half of 4 is 2, square it, and that gives you your constant here. And then whatever's on the outside has to multiply by that. That gives you 8, and that's what you subtract off here. Now, if this had been a negative sign here, then half of -4 would have been -2. -2 squared is still +4, so you've still been subtracting. Yeah, okay.
Okay, what happened to 2x plus 2 squared minus 1?
Okay, down here?
Yeah.
Okay. This is how I like to do it. As soon as you take half of this, write it down here.
Okay.
If this is a +4, You did half of that is a plus 2, right? X plus 2 down here, put it in parentheses. That's going to be your answer. Because this square is that. That's what completing the square is. You make this a perfect square, that is what it's the perfect square.
So basically you just half.
What's that?
You split it in half.
Square of half. Oh, you squared half of the board, yeah. And then you combine these together and you get this. Now, if this had been a negative 2 out here at the very beginning, when you factor that out, be sure you change your sign in here, go through the steps, but then whatever you had in here, then multiplied by negative 2 times 4 would have been a negative 8, then you put a plus 8 out here. So be sure you keep up with your signs. I tell all my math classes this at some point. Negative signs are only out there to trip you up. That's what they're there for, you know. They're just looking for a chance to, I'm just kidding. They negate things. Okay. Say again? All right. Okay. Want to see how they did it? Okay. I imagine it's not going to be a lot different from what we did. Let's see. Begin by writing the equation over. Oh, I'm glad they put that step in there. Okay. So write the original function. They did. We already used the one they had. Then the next thing they do is factor out the a, the 2, from only the first 2 terms, only the terms that have x's in them. Now, they keep it all written close together. I don't like that. I like to have space there so to remind you you're going to be completing the square. So that's what I don't like. But they did the same thing. Factored out the 2, giving you this, and then the plus 7's on the outside. Okay? Now, next is half of this. Half of 4 is 2. Square it. And as soon as you say half of this is plus 2, down here write x plus 2 squared. You know that's going to be the answer. Okay, but half of that is plus 2. Square that and you get another plus 4 in there. Okay? And they're going to write it here. And if you like the way they do it here, that's fine. I find it really obnoxious. But I'm saying, this is what we did. Half of this is 2, square the 2, and you get 4. They wrote the minus 4 in here. I say you just change this by adding 8 to it, subtract 8 over here. They write it here and then have to move it around. It's fine. If you like this, do it this way. It's doing the same thing. Now, after adding and subtracting the 4 within the parentheses, you must now regroup the terms to form a perfect square trinomial, keeping the plus 4 in here and moving the minus 8 out here, which to me, you could have done just in one step. The minus 4 can be removed from inside parentheses. However, because of the 2 on the outside, you must multiply the minus 4 by 2, which is a minus 8 in here, and you move the minus 8 out there. It just, here they did it. They did the 2 times the minus 4 out here. Then if you see that better than the way I did it, do it this way, okay? To me, it's too many steps, okay? And they're a little confusing, but it works. That is perfectly fine. It's the same thing we got. It's 2 times x squared plus 4x plus 4 minus 8 plus 7. I just had the minus 8 on the other side of plus 7. It doesn't really matter, okay? Now, that thing in parentheses is the perfect square of x plus 2. That's why I said as soon as you take that half of b, you've got that part of your perfect square. That's going to be 2 times x plus 2 squared, and then you combine minus 8 plus 7 is minus 1. Okay? And that's why I say rather than having to think through this, as soon as you take half of this, write it here. Put it in parentheses. Okay. It's done for you. From that form, you can see that the graph of f is a parabola opening upward. Why is it opening upward? How can you tell that's opening upward? The only thing this number does for you is tell you the A. And where's your A? This problem. this 2 out here. And because that's a positive 2, it has to be opening up. If that had been a negative 2, opening downward. And because it's a positive 2, it's going to open pretty narrowly too, because that's a number greater than 1. Okay? If that had been a 1/2, which it could be, it would have been wider. Okay? Negative 1/2 would have been like that. Okay? Remember what these say. The A tells you, the sign of A tells you whether it's opening up or down. So it's a parabola opening upward. And what's its vertex? -2, -1. The opposite of this is exactly what that is. That's it. What's your axis of symmetry? X equals -2. Just write that in. X equals whatever your H is. -2. Okay? Now, corresponds to a left shift because, remember, whatever you're doing to the X is always backwards. So it shifts 2 to the left and down 1. There it is. Okay? There's your vertex. -2, 1. Right there. Now, what I did that they didn't do was take advantage of that first form when you have f of x equal 2x squared plus 8x plus 7. That plus 7, that one right there, tells you your y-intercept, which would be 1, 2, 3, 4, 5, 6, 7, right here. Okay? And you do that, and then you go on the opposite side of this 2 units to the other side, and at -3, you'll be at plus 7. Okay? Use everything they give you. Okay? Now, they did their parent function here is not y is equal to x squared, but y is equal to 2x squared. And now these two have the same shape. Okay? I would have done x squared, which would have been a little wider here, and then said this is a stretch, a vertical stretch, plus a vertical and horizontal stretch. But it works out the same. And surprisingly, that looks a lot like ours. Maybe not quite as pretty as mine, but close. Okay. Right. Okay. Got it? Any questions? All right. In the figure, you can see the axis of the parabola is the vertical line through x equal -2. Through the vertex, x equal -2. That is your axis of symmetry. Always written x equal whatever your h is. Okay. To find the x-intercepts of the graph, you set, and this is like you did back in quadratics, because what you do is set that first expression that you had there equal to 0, because your x-intercept is where y is equal to 0. Where is y is equal to 0? Somewhere on the x-axis here, because you've got to, when y is 0, you're either up or down, you're on the x-axis. Okay? So you set the y, f of x, equals 0. And then you solve this just like you did back when you were in Math 100 or 112. You factor if you can, and if you can't factor, you use the quadratic formula, and we all know and remember that and love it too, right? Anyone remember what the quadratic formula is? Now, in the quadratic formula, you have to be in this form. And once you're in that form, you have x equal, this is just tells you x. Anyone remember how it goes? Minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the quadratic formula. So know that. Write it down, take it with you. You remember, you get to use a formula and equation sheet? I hope all of you brought one for your test, didn't you? I know a few of you turned it in, so I know some of you had one. Huh? One page where you can write front and back as big or small as you want to write. Okay? And by the way, making, say again? I can't hear. Okay. Well, that's okay, but what happens then, you spend all your time flipping through pages. if you really condense it and get the important stuff, what you think may be important, organize how you know it is, it's a lot easier to find if you have it on one page. Huh? Oh, she wouldn't. I told you beforehand, one page. Okay. I said a formula or equation sheet. Singular. Okay. All right. Now, they also have another issue here. Some parabolas don't have y-x-intercepts. Okay? Let me just do an artificial parabola here. Here's a parabola. How many times does that cross the x-axis? Never. How about this one down here? Never. Okay. Only, and occasionally have only one intercept when it touches just one place. Most of the time, they will be two, one here and one there, but not always. You may have zero intercepts, one intercept occasionally, or a lot of times you have two. Okay, depending on this. If you wind up with this thing in here being negative, there aren't any intercepts. Okay, if this is positive, but not zero, positive, then you'll have two intercepts, one for the plus and one for the minus. If you have this turning out being zero in here, then your one and only one intercept will be minus b over 2a. We'll come back to that a little bit later too. Any questions? Okay. Let's see, did they skip any? I think they did, didn't they? There was example 2. And by the way, I didn't say it. I should have said it every time. After every example, guess what there is? A checkpoint. And checkpoints have their answers at larsonprecalculus.com. So please do the checkpoints. Okay, they skipped example 3 and example 4. How are we doing on time? Huh? 42. We got 3 minutes. Ooh, huh? You want to do one? Okay, let's try to do number 3. Oh, there was a good place to do it right there. Okay. Sketch the graph of f of x is equal to minus x squared plus 6x minus 8. Okay? Identify the vertex and intercepts. Don't think we're going to have time for all of it. Let's get started. Where would you begin? I'm going to write down all the silly steps now. Minus x squared plus 6x blank minus 8. All I did was stretch that out. Now what's the next thing you're going to do? Factor out what? That negative 1, exactly. So that'll be a minus 1 times what's left? X squared. What's that? Minus 6x. Perfect. Blank minus 8. Okay, y'all get tired of blanks, don't you? Yeah, I can tell. Okay, now what do we do next? Half of negative 6 is negative 3. And you can, if you want to, just come down here, write x minus 3 squared. You don't have to do that now, but it's just so easy because you just did it. Okay? Now, take that minus 3. Half of minus 6 is minus 3. Square it, and what do you get? Plus 9. Perfect. Okay? What's that? Okay. You did 2 things there. Okay, I haven't done that yet. Okay? You take half of the minus 6. That's a minus 3. Well, you can just write down your minus sign, your parentheses, and put x minus 3 squared. Just do that. As soon as you take half of that minus 6, write it there with an x and square it. Okay? But you also, with that minus 3, square it. And what's minus 3 squared? Positive 9. So write down your plus 9. But don't stop there, because you just have changed your problem. You actually subtracted 9 here, didn't you? Because you had a minus out here, times 9, that's a minus 9, so what do you put over here? Well, plus 9. plus 9, okay? So you put a plus 9 here. So now you already have written this part, minus x minus 3 squared, and what you have here? Say again? Plus 1, okay? I think we can write our vertex down, can't we? What is your vertex? Say again? Positive 3, 1. Perfect, perfect, perfect. I think you can write down your axis too, can't you? What's that? X. Woo. X equal 3. That's it. There's your axis right there. And now sketching it is pretty easy. Right? I know are we out of time? Okay. Are we going to sketch it next time, or we want to go and sketch it now? Sketch it now. Okay. It won't be hard. Won't be hard at all. Okay? It's going to be a little ugly, but it won't be hard. Okay. Now, your vertex is 1, 2, 3, up. Oh, I didn't do my ups. Okay. 1, 2, 3, and up 1. Okay, right there. And I don't have room for it, but your y-intercept would be minus 8 when your x's are 0. So somewhere down there it's going to cross the, I didn't draw it well, so this would be, I got minus 5. 3 more down would be that one. Okay? Your axis of symmetry, x equal 3, right there. Okay? And then you go plus or minus 1 unit, and you wind up with your intercepts right there. Okay? I didn't show you how to do that, but you could do it. Okay? All right. And then the next one will be 2, 3, 4, right there and right there. Okay. We'll talk about how to do that later. But that's going to be how your graph looks. Okay. But we'll begin that next time. We'll start with the graph then. Okay? We already have done all the hard work. We'll just do the graph next time. All right, wait, let me give you some homework exercises, because y'all want those. I know you do. We almost finished 2.1, by the way. You can do either 5 or 7. They're both at Calc Chat. In fact, I would do all 4 of those, 5 through 8. Only the answers are at Calc Chat or the back of the book of 5 and 7. Okay? Then any of the odds, 9 or 11, both at Calc Chat, 9's at Calc View. Any of the odds, 13 to 25, all at Calc Chat, 17's at Calc View. 27 to 33, all at Calc Chat. 35's at Calc Chat. And we'll pick up the rest of those and do them next time. All right, good deal. Thank you. First paper in. All right. Okay.
For the vertex, do we just take the B and do the opposite? Or?
Yeah, it is whatever this number is here, but the opposite sign. So
Okay.
that'd be 3. And that's what the x equals to.
And when we scheduled to take the test?
What's that?
When we scheduled to take the test?
Okay, you haven't taken it?
No, when do we schedule?
Anytime you want to come
I'll
by,
do
do my
Friday.
office hours. Friday?
Yeah,
You want to take it to Birmingham County? Remind me Thursday.
All right.
How
Okay.
long do you have, like,
What's
right,
that?
how long do you have available right now?
Right now, I have 15 minutes before my next class, probably less than that now, but I can get you started next door.
Okay.
You want to start next door? Is anyone over there?
You said we can enter our kit. Looking like that, then we do our kit.
You can fill in any that you left blank. Any
Okay.
that you have done already, they're already
I can
great.
do that.
Okay. You want yours now?
Oh,
Okay.
if I come back at what time I can come back?
Okay. What time do you want to come back?
That's fine. You talking about this class right here?
Yeah.
Ain't nobody else.
Nobody's there.
Oh, what about Wednesday?
Wednesday from 8 to 10 in the morning?
Yes, sir.
Okay. I'll be in my office. You know where that is? That's tomorrow, Wednesday, right?
Yes, sir.
Okay, right.
When? Or where?
Okay, 265. You know where the orientation classroom is?
Yes, sir.
Right across the hall.
Okay.
Did I get you when you came in?
Oh, no, sir.
What's your name?
Drake.
Huh?
Drake.
Drake. Oh, yeah, I remember. Okay. I kept looking and saying, did I catch you? There you go. Okay. And who's going to take it now?
I just need to fill in some.
Huh?
I think I left some stuff blank.
Yeah, I know you did. Everybody, all but one person did. Okay, remind me of, here's Keelan. Well, you finished yours, didn't you?
Oh, I didn't finish.
Oh, that's your quiz. I'm sorry. I didn't remember that you finished. Okay, quiz. Patricia. Okay. Oh, I'm sorry. I'm sorry. What's that?
Cornice.
Huh?
Cornice.
Cormisha. I'm sorry, I misunderstood. My hearing's terrible. Keelan. There's yours. Okay. And you grade it that to the top. That's what you got so far. It can only go up. Okay. Okay. Are you waiting for a test too?
No.
Oh, okay.
Well, I'll talk to you.
Okay, right. Okay.
And we gonna have a grade for us in the computer.
I'm sorry?
We gonna have a grade for us in the computer, like on Blackboard.
When you finish your test. Oh, you mean the quiz?
Just period.
Huh?
Just period. is not a
Standard grade.
Like a
Okay.
standard grade.
I'm trying to do it right now. Here's yours. Right now, I'm trying to get fall schedule done.
Fitzpatrick.
And I know I must, yeah, I had yours right there. Okay, as soon as I get a break from the fall schedule, and I'm working on that, yeah.
Do mines on Monday.
You what?
Mondays.
Your test? Yeah.
'Cause I won't have nothing but like 10 minutes if I did it today because I have to log back into work.
That what?
I said if I did it now, I won't have nothing but like
Right.
10 minutes.
Okay.
because I have to
Yeah,
log
Monday's
back
fine.
into work.
Yeah, 8 to 10 or 3:45 to 6?
It'll be between the 3:45 and 6.
3:45 to 6. Okay, I'll probably be down in my office. If I'm not there, check up here because I'll get out of class here at 3:45. If they have questions or doing stuff up here, I may still be up here. So either up here or down there. Usually our work studies. Well, let's see. No, she's not there that late. But if I'm in either place, just wait. I'll show up.
Okay.
Okay. Yeah.
Did you grade it?
I'm sorry.
Did you already grade it, right?
Yeah. Well, what you've done so far.
I want to see it.
Huh?
I just want to see if I can see it.
You want to do what?
I want to see it.
Okay. Right.
Back numbers.
Yeah. Okay. And that's what you got so far. Anything you get from there is on, don't go higher.
Here's Shankita.
Oh, you want to see yours too? Sure. All right. What's the last name? Rogers. Okay. I know some first names, but last names I'm not sure. And it can only go higher.
Okay. You said mine ever. So I thought I was doing it. I was doing for each one. I thought it was what you
But all you did was write this here and this there. You didn't show algebraically.
There you
Oh, okay. Okay, I didn't see this.
go.
I think I looked at the last page and that wasn't it, so I didn't know to look in the middle. Okay, I'll regrade that part.
So like I can make a plan.
Yeah, I mean, you got several blanks here. And this, just to let you know, most people end up dropping this test. So, but still, you need to know this stuff because we're going to use it in the next test too. Okay. All right.
Well, I thought I had practiced everything, but I practiced like Sunday school.
What?
I thought I practiced everything. I don't know.
Well, actually, now that I see your work, you were doing, well, you see, like this one, I found where you made your mistake.
Mhm.
You did -2 times -3. No. Yeah, you did 3 times a -3, and you did a -6. It was a -9. No, 3 times.
Okay.
Times is 9. You added. Not, well, you kind of added and kind of multiplied at the same time. So,
I got test anxiety too, so I just.
okay. But, yeah, you're in good shape. May not feel that way, but you are. So,
You figured it out. The last one.
uh-huh. I don't know. I mean, that looks good.
Teach me.
All right. Anybody else? Oh, you're here for next class, right? All right. Sorry. Let me.
How's your appointments go?
What's that?
How's your appointments go from last year?
I'll tell you that in a minute. Let me go on and shut this down.